Hi colleagues, finally we are at the last two questions that we didn't get to do in the tutorial class, and we are going to explore using both methods, both the ratio and proportion and the dimensional analysis method. Question says, a physician advises an adult patient to take a children's tablet, and this children's tablet is 81 milligrams of aspirin per tablet. He instructed the patient to take one of that tablet daily as a precaution against heart attack. Instead, the patient decides to cut 5-grain aspirin tablets into dosage units. How many doses could be obtained from each 5-grain tablet? So what's the first thing that we need to do? Using ratio and proportion, the first thing we need to do is to write down what is known. What is known is that one dose is equivalent to 81 milligrams. That's what the doctor is telling the patient to take. But the patient is using 5-grain tablets. So we need now to write down related conversions, because we need to determine, since the patient is now using fractions of this 5-grain tablets to get the 81 milligram dose, we need now then to convert to common units. So we're converting the grains to milligrams. Conversion is 1 grain is equivalent to 65 milligrams. So when we convert that, since 1 grain is equivalent to 65 milligrams, then 5 grains will be equivalent to X. We set up our cross multiplication setup. And we have 5 grains times 65 milligrams divided by 1 grain makes 325 milligrams. So this means that the 5-grain tablet will contain or is equivalent to 325 milligrams of aspirin. So then, we need to determine the total number of doses that can be had from the 325 milligram aspirin tablet. We know that one dose is equivalent to 81 milligrams, so therefore we can determine how many doses will be equivalent to 325 milligrams. We set up our ratio and proportion thing. 325 milligrams times one dose divided by 81 milligrams is now going to be equal to that amount of 4.012 doses, or approximately 4 doses. I want us to recognize that writing units help us to recognize if we're on the right track, if our numerator should be the denominator and vice versa, because that happens sometimes, especially if we don't set up our layout properly, putting apples on the apples, eggs on the eggs, then you might switch it around and remember, put it in your calculator. Calculator is not going to tell you, oh, you did the wrong setup, you need to check again. Garbage in, garbage out. Whatever you punch in the calculator, you're going to get an answer. So you have to be very careful. That is why I insist that we write our statements. You don't have to write as long a word and sentence as I did. You can use arrows to indicate that there is a relationship between one unit to another. But for you and for clarity and also for accuracy, writing your units is so important. Alright, so let's look at the dimensional analysis. Again, we need to set up our dimensions to get from what we have to what we want. And what we have is 5 grains, and we need to somehow end up with number of doses. And between that, what conversion factors do I need to multiply by this 5 grains to end up with number of doses? So, conversion factor, 5 grains times 65 milligrams over 1 grain is going to end up with 325 milligrams. Notice how I set up my dimensional analysis. I have 5 grains, but I want to end up with milligrams. How do I do that? I need a conversion factor. Conversion factor says 1 grain is equivalent to 65 milligrams. But how can I use that information multiply it by 5 grains to end up with milligrams. It means then the grains must be in the numerator, milligrams must be in the denominator. So, numerator is at the top, denominator is at the bottom. I'm saying it wrong. Excuse me. You need to have the grain at the bottom or the denominator, and the numerator needs to be milligrams, so that when you multiply it by 5 grains, the grains will cancel out. What's next? So now we need to move from milligrams to number of doses. What's the conversion factor that will relate milligrams to doses? Remember that 1 dose is equivalent to 81 milligrams. So if we multiply this conversion with the 325, we're going to end up with dose because milligrams are going to cancel out. Again, we need to say to ourselves, what must be the numerator? What must be the denominator? Just in case Miss Price get those terms wrong again, what must be at the top and what must be at the bottom in order to multiply by this 225 milligrams in order to get doses. Right away, you know that milligram need to be at the bottom, dose need to be at the top. So you arrange it in such a way so that when you multiply the 325 times that conversion factor, you end up with doses. And so we end up with 4 doses. Notice the limited amount of steps. You don't have to have a whole lot of explanation or statements, etc. However, you need to know what conversions to use, what needs to go at the numerator, what needs to go at the denominator. Let's look at one last question. This is the last one that we didn't get to do in our tutorial. If 1 fluid ounce of cough syrup contains 10 grains of sodium citrate, we want to find out how many milligrams are contained in 5 mils. Step 1. Write down what is known. We know that 1 fluid ounce of syrup is going to contain 10 grains of sodium citrate. We need to also write down the related conversion. And the related conversions would be the grain equivalent to milligrams and the fluid ounces in terms of US equivalent to milliliters. Then we're going to put these units, have common units to work with. So we're going to convert the grains to milligrams and we're going to convert the ounces to milliliters. Since 1 grain is equivalent to 65 milligrams and we know 10 grains will be equal to X, and we set up our ratio and proportion and we get 650 milligrams. So the next step then would be to convert the fluid ounces to mils. We already know what that conversion is. 1 fluid ounce is equivalent to 29.57 mils, which now contains 650 milligrams of the drug. So if 650 milligrams of the drug is contained in 29.57 mils, then we can determine how many milligrams will be contained in 5 mils. And that works out to be 109.99 mils. Again, you need to write your statements because it needs to have a logical flow when you're using ratio and proportion. So if we're using dimensional analysis, again, we're going to set up the dimensions to get from what you have to what you want to get to. We want to get somehow 5 mils and end up with milligrams. How do we do that? We have to write down the conversion factors. So 5 mils times 1 fluid ounce over 29.57 mils. Why do we set it up that way? Because we know the conversion factor is 1 fluid ounce is equivalent to 29.57 mils. But we have to set it up in such a way that when we multiply that conversion factor times the 5 mils, we end up with fluid ounces. So it means that the mils need to go to the bottom and the fluid ounce need to go to the top. So the mils will cancel out to end up with the amount of fluid ounces that will be in, say, 5 mils. That's exactly what we're doing, right? Then we need to now multiply that value in terms of fluid ounces times another conversion factor to end up with grains. And what's the conversion? Conversion is that every fluid ounce will contain 10 grains. Now, we need now to set up our dimensional analysis in such a way, or set up that conversion factor in such a way that the fluid ounces at the bottom and the grain is at the top, so that fluid ounces can cancel out. So we multiplied fluid ounces times 10 grains divided by 1 fluid ounce. So we're going to end up with an overall answer of grains now. But then we need to end up with milligrams. So how do we end up with milligrams? We have to multiply the overall value, which is grains, times another conversion factor to end up with milligrams. And what's that conversion factor? 65 milligrams is equivalent to 1 grain. Now remember, you have grains, we're multiplying it by a conversion factor. So that means the conversion factor must have grains at the bottom and milligrams at the top, right? And when you do all of that, you end up with 109.91 milligrams. So dimensional analysis is quite simple as long as you get the hang of it and you know what needs to be at the numerator, what needs to be at the denominator, what needs to be at the top, what needs to be at the bottom in order for the units to cancel out, then you're good to go. This is totally fine, but you need to place your units there. Alright? So I do hope that this explains a little bit more on dimensional analysis. You can also view some videos on YouTube. They explain it very well, much better than I can, to supplement this lesson. Alright, all the best, and I'll see you when I see you.